The goal is going to be doing the reverse of what we've done the last two lessons, which is going to be determining a rule for a piecewise function. The function in particular we're going to look at today is this one here, which you can see is made up of three different pieces: a red part, a blue part, and a black part. And we're going to be working out how to actually write it. So I always suggest, whenever dealing with a piecewise function, whenever you're trying to determine the rule, start with the domains, because that's the easier part. So my function, f of x, is equal to three separate functions: a red function, y1, a blue function, y2, and a black function, y3. I don't know what these functions are yet, but I do know their domains. It's actually quite easy to read off. The domain of the red part is between 0 and 1. In particular, though, it's a hollow point at 1, but a solid point at 0. So I can say x is between 0 and 1, but it is a solid point at 0. It's a hollow point at 1. So that's going to be my bracketing. Let's do the blue one next. Well, the blue one is solid at both sides, so it's going to be less than or equal to for x, and it's from 1 to 4. Based on the fact that it starts at x equals 1 and it finishes at x equals 4. So you can see even on the picture it's going from 1 to 4. And the black one, well, that one's going from 4 all the way up to 8. At 4 it's not include. Oh, sorry. This is where we're going to have to look at the original picture. The original picture has this as a blue point, same as this one is a blue point, meaning that 4 is not inclusive for the black one, and neither is 8, because you can see it's a hollow point there. So hollow point means that it is not going to be inclusive. So I've set out my domains, and now I just need to work out the equations of three different lines. Let's start with the first one, the red line. Now, the red line we already have 2 points for, so let's work out y1 is equal to mx plus c. We're going to use the standard form for an equation for a line, and we're just going to work it out. Now, the gradient is equal to delta y over delta x. The change in y is 3, the change in x is 1, so the gradient is 3. The y-intercept we can actually read straight off. It's negative 2. It's where it hits there. And so we get y1 is equal to 3x minus 2. You can double check by substituting in 1, checking you get 1 as an output, and substituting in 0 and checking you get negative 2 as an output. That's an easy one. So I've already figured out the equation of y1. It's 3x minus 2. y2 is equally easy. y2 is a horizontal line, meaning it's y2 equals c, or you can say y2 equals mx plus c, but m is equal to 0. It's a flat line. Therefore, y2 is equal to c. And in this case, we know what c is. You can see that the horizontal line is at 2 high. So c is equal to 2, y2 is equal to 2. Notice I'm not putting anything else. I'm literally just putting 2. Now, y3 is the only interesting one of these lines here. We've got the 2 points that it's going through. It's 4, 2 and 8, 0. Notice that's the x-intercept, not the y-intercept, so it's not going to help us find the equation. So let's have a look and see if we can find y3. Well, it's going to be an mx plus c because it's a standard line. It should have a negative gradient because it is going down to the right. And the gradient in this case is going to be delta y over delta x. It's gone down 2 and it's gone across 4. So that's negative 2 over 4, or negative a half. The c1 is going to be a little bit harder to find out. So far we know what the gradient is. It's negative a half. So we're going to have to substitute in one of the 2 points. It's your choice whether you prefer 8, 0 or 4, 2. In this case, I'm going to sub in x, y is equal to 4, 2. You could have done 8, 0. You're going to get the same value for c either way. So replace y with 2. That's 2 on the left-hand side. And replace x with 4. Negative a half times 4 is negative 2, so we get 2 is equal to negative 2 plus c. Add 2 to both sides, and we get 4. C must be equal to 4, therefore y3 must be equal to negative a half x plus 4, and we can pop that into the last one, negative a half x plus 4. And that is the equation of our function. But how could we check something like this? It's all well and good to say, oh yeah, we've done it, but how can we check it? So there's a few ways you can do it. On your calculator, it's a little bit different. I'm going to show you how to do it on Desmos. Now, Desmos is a free and fabulous tool. You can use it directly on your Windows computer right now. You can just open up in a tab in Chrome and type in Desmos, and you can start playing around with it. It's a really useful function, and it's a really useful tool, especially for stuff that we're going to be doing. So let's just type in our different functions. So our first function was 3x plus, minus 2. Our second function was y equals 2. And our third function was, what was it? It was negative a half, y equals negative a half x plus 4, I think it was. Let me just double check. Yeah, negative a half x plus 4. And so you can kind of see that, yeah, well, it sort of looks similar-ish, but it's hard to say for sure because I haven't been able to put the domains in. So it's just drawing 3 lines on top of each other, which is nice and all, but it'd be good if we could actually see where these lines are meant to start and finish. And we can do that using particular notation. And in this case, the particular notation is using square brackets. My apologies, it's not square brackets, it's actually curly brackets. And you can see how I've just put the first one in. I've just put the domain inside curly brackets, so 0 less than or equal to x less than 1. For the next one, it's going to be the same, so it's going to be 1 less than or equal to x less than or equal to 4. And for the last one, the range is going to be 4 less than x less than 8. And there you can see the whole function. Now you'll see that Desmos isn't very good at showing you the ranges, but you can actually see that it actually puts a hollow point at the end, but you have to select the points there. It doesn't work quite naturally, but you can see it's a hollow point here and here at the end points, whereas on the green line, you can see it says it's undefined on each side. And so that's one way of actually doing up a piecewise function in Desmos, and you can check that it looks quite similar to the picture we started with. Alrighty, I'll see you in the next one. Bye.